Okay, so today we're going to take a look at 4.5, which is over quadratic equations. So just as a refresher, what we just got done looking at was factoring quadratic equations of case 1, case 2, and difference of squares. And I had mentioned that the reason that we want to factor quadratics is that once we factor those, we can find our x-intercepts, and that's what we're going to actually take a look at doing today. So it's not going to add a whole lot on top of what we had already been doing with our factoring. So the first thing that we're going to take advantage of is what is known as the zero product property. The zero product property just states that if you have two numbers, a and b, and you're multiplying those two numbers together and the result is 0, then you know that a is equal to 0 or b is equal to 0. It's also the possibility that both a and b are equal to 0. This is what we will be using to be able to find what are known as the zeros of a function, and that is just going to be the x-intercept. So we call this the zero of a function. Sometimes you will also see this as a root or even possibly a solution. So we have kind of three different names that we'll use. Zero, roots, and solutions all mean the exact same thing, and they are all just x-intercepts. So now what we're going to be doing is actually taking equations. So previously we just had a quadratic and we didn't have an equation because we didn't say it was equal to anything. So now we have x squared minus 5x plus 6 is equal to 0, and we're going to solve this by factoring. So I have a case 1 quadratic that I'm going to factor and actually solve. So first thing we want to do is just factor our case 1 quadratic. So we're going to end up with two sets of parentheses, and that's going to be equal to 0. So case 1, I look at my c value, what multiplies to give me 6, adds to give me my negative 5. Well, negative 3 and negative 2 work, so x minus 3, and then x minus 2. Previously, we would have stopped here, and we would have been done. But now, because we're solving, we're going to use the zero product property, which tells me that if I multiply this x minus 3 and this x minus 2, and the result is 0, I know that either x minus 3 is 0, or x minus 2 is 0. So I then say x minus 3 is equal to 0, and x minus 2 is equal to 0. I'm going to take and solve both of these two equations, and that will give me my x-intercepts. So the first one, you would just add 3 to both sides of your equation, and you get x is positive 3. Over here, you would just add 2, and you get x is 2. So that means that your solutions, your roots, your x-intercepts, are 3 and 2. So if you were to take 3 and 2, plug those back into the original equation, that would give you 0 is equal to 0. Same thing with if you take your factored form and plug in 3 or 2, you will end up with an answer of 0. So that's really all we're going to do. We are going to take our quadratic, we're going to factor the quadratic, and then once we have our factored form, we're just going to set both of those equal to 0 and solve. So here we have a difference of squares, which actually has a greatest common factor. So the first thing I'm going to do is I'm going to factor out my greatest common factor. 4 and 36 are both divisible by 4. So you get x squared minus 9 is equal to 0. Then I'm going to take this x squared minus 9 and factor that. So on the outside you have 4x plus 3, x minus 3 is equal to 0. Because my greatest common factor is just a number, because I'm looking for a solution, this actually isn't going to do anything. So I could easily imagine dividing both sides by 4. If you divide both sides by 4, then what happens is that this just goes away and you're just left with x plus 3, x minus 3 is equal to 0. And then we just say x plus 3 equals 0, x minus 3 is equal to 0. Hopefully at this point you're starting to see that this is pretty simple, and we would end up getting x is a negative 3 and x is a positive 3. So my two solutions would be a negative 3 and a positive 3. So here's the first case where what we have to do before we even attempt to factor is make sure that we are equal to 0. So on one side of your equation, you have to have 0. If you don't have 0, we cannot use the zero product property. And if you cannot use the zero product property, it's not possible to find solutions. So I need to move this 5 to the other side of my equation before I even attempt to factor. And we get x squared plus 8x plus 16 is equal to 0. Now I can go ahead and factor this. What multiplies to give me 16 adds to give me 8. Well, we have x plus 4 times x plus 4. So now we have the same thing in both sets of parentheses, which means that what's going to happen is that when I set both of these equal to 0 and solve, you're going to get the same answer. So I only need to actually solve for one of them. So x plus 4 is equal to 0. You would subtract 4 from both sides and get x is equal to a negative 4. So that means that our solution is negative 4. Here's another example, and this is going to be a case 2. Before we factor, I need to get this equal to 0. So you subtract 4 over, you get 5x squared plus 8x plus 3 is equal to 0. It's a case 2, so you're going to take your a value and your c value, multiply those together. So 5 times 3 gives me 15. I need to figure out what multiplies to give me 15, adds to give me my middle value of 8. Well, luckily enough for us, 5 and 3 work. So we say x plus 5, x plus 3. Because this is a case 2 though, I need to take my a value and set up fractions, simplify them if I can. So the first one does simplify to x plus 1. The second one will not simplify. We're left with a fraction, so we move the 5 in front of the x, and you get 5x plus 3 is equal to 0. Now we'll go ahead and take both of these sets of parentheses, set them equal to 0. So x plus 1 is equal to 0, and 5x plus 3 is equal to 0. Solve your equations, you get x is a negative 1. Over here, when we solve our equation, we're going to get x is equal to a negative 3/5. So our two roots, or x-intercepts, one of them is going to be negative 1. The other one should be negative 3/5. So here's another example in which I have x squared equals 18x. I need to get this equal to 0. I could move this x squared to the right side, but we always want to try and keep the x squared term as a positive because it's much easier for us to factor. Otherwise, we would have to flip all the signs. So we'll go ahead and subtract 18x over. You get x squared minus 18x is equal to 0. Now I need to look for a greatest common factor, which the greatest common factor is going to be x, because both of my terms on the left side have an x. So if you factor out an x, x squared factored out an x leaves 1x. Negative 18x, you factor out the x, you're left with a negative 18, and then that's equal to 0. This is now in factored form, so now I'm going to set my parentheses along with my greatest common factor equal to 0. Previously, when we factored out the greatest common factor, this 4, because it didn't have a variable, we kind of just dropped it because we don't actually need it. Here, I can't just ignore this greatest common factor because it's a variable and it's going to be part of my solution. So we're actually going to take this, x, and set it equal to 0. So there's one of your x-intercepts. And the other one is going to come from x minus 18 is equal to 0, which is just going to give us x is equal to 18. So our two x-intercepts are 0 and positive 18. Here's just a slightly more complicated version in which all I'm going to do is move everything to the same side of my equation. So I'll subtract 2x and subtract 12, subtract 2x and 12, and you get 2x squared plus 5x minus 12 is equal to 0. So now it's equal to 0, so now I can attempt to factor that. This is a case 2, so you do 2 times negative 12, so a times c gives me a negative 24. I need to figure out what multiplies to give me negative 24, adds to give me 5. Well, 3 times 8 gives you 24. One of them needs to be negative to get a negative 24. I need a positive 5. So if I make it a negative 3 and a positive 8, multiplies to give me negative 24. Adds to give me a positive 5, so negative 3 and 8 are my numbers. So x minus 3, x plus 8 is equal to 0. It's a case 2, so don't forget to set up your fractions with your a value. Simplify if you can. First one does not simplify, so this 2 goes out in front of the x, so you get 2x minus 3. This does simplify, and you get x plus 4. Now we're going to take both sets of parentheses, 2x minus 3, set that equal to 0, x plus 4, set that equal to 0, and solve. Over here you would add 3, and you get 2x is equal to 3, divide by 2, and you get x is equal to 3 halves. This one, you're just going to subtract 4 and get x is equal to negative 4. So your roots, or your x-intercepts, would be 3 halves and a negative 4. So that pretty much covers what we're going to be doing in 4-5 quadratic equations. You want to make sure that your quadratic is equal to 0. Once it's equal to 0, you want to first look for a greatest common factor. If there's no greatest common factor, you're going to factor it as a case 1 or a case 2. Once you have it as a factored form, you're going to take everything that has the x, set that equal to 0 and solve, and then those will be your x-intercepts.